Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 5, Modeling from a Sequence. So, classwork says opening exercise. A soccer coach is getting her students ready for the season by introducing them to high-intensity interval training, or HIIT. She presents the table below with a list of exercises for a HIIT training circuit and the length of time that must be spent on each exercise before the athlete gets a short time to rest. The rest times increase as students complete more exercises in the circuit. Study the chart and answer the questions below. How long would the 10th exercise be? If a player had 30 minutes of actual gym time during a period, how many exercises could she get done? Explain your answer. Okay, so the first thing we need to do is determine what the quantities and variables that are needed to solve this problem. So they're both related to the number of exercises. So I would start by naming the number of exercises n. So if n is 1, it's exercise 1. If n is 2, and so on. Then we have exercise time and rest time. So if we say we have a function e of n, that's exercise time with respect to the exercise. So how much time in exercise 2 would be 0.75, e of 3 would be 1, e of 4 would be 1.25, and so on. And then this is rest time, so this could be r of n. So there's our function names, and the variable is n itself. Okay, so now the next thing we want to do is determine if it is a geometric sequence or an arithmetic sequence. So I've brought this table in, and we want to look for a common difference or a common ratio to determine if it's geometric or arithmetic. So if I look at the length of rest time, this is going to be blank right here because there's no length of time between not exercising and rest. There is no rest there. You begin the exercise and you exercise for 0.5 minutes and then you rest between exercise 1 and 2. So the rest time between after exercise 1 was 0.25 minutes, and then exercise 2 was 0.5. So you take 0.5 minus 0.25, and the difference is 0.25. So that goes right there. And we continue doing that until, I'll put a 0 in there too. Okay, and then we're going to 1 minute minus a half a minute. Exercise difference. 0.75 minus 0.5 is 0.25. 1 minus 0.75 is 0.25. 1.25 minus 1 is 0.25. And 1.5 minus 1.25 is 0.25. So right there we see that the length of exercise time has the same common difference of a quarter of a minute, or 15 seconds. Okay, we're increasing 15 seconds in time after each exercise. So E of n is arithmetic. So we don't need to check for a common ratio because we already know there's a common difference. Okay, so I made another table, and this time we're going to focus on the rest time. Last time we did exercise time. So the exercise increased by 0.25 minutes or 15 seconds every time. Now we're going to do exercise number, rest time, common difference, and see if there's a common ratio. Okay, so now I've created this table. Exercise number, rest time is already entered, which is from here. So what I did was took this column here and moved it to right here. So there's my rest times. So the common difference now, 0.5 minus 0.25 is 0.25. 1 minus 0.5 is 0.5. So right there we see that the common differences are different, so therefore it is not an arithmetic sequence. 2 minus 1 is 1. 4 minus 2 is 2. So there's the common differences. A quarter, a half, 1, and 2. So then we want to do common ratio. And in order to find common ratio, you take exercise 2 rest time divided by exercise 1 rest time, or 0.5 divided by 0.25. And that will give us 2. And then we take 1 divided by 0.5, and that will give us 2. Then we take 2 divided by 1. 2 divided by 1 is also 2. 4 divided by 2 is also 2. So we have a common ratio of 2. Okay, so now we need symbolic representation. So for this one, you would say E of n equals, now remember this was arithmetic, so an arithmetic sequence is equal to its first term, 0.5, plus the common difference, 0.25, times n minus 1. So there's our equation for our arithmetic sequence on exercise time. Rest time, I'll do in purple. I would say rest time, R of n, since we did find that it was geometric, a geometric sequence is the first term, 0.25, times the common ratio of 2 to the power of n minus 1, where n stands for exercise numbers and n has to be greater than or equal to 1. Okay, same with our rest time. Okay, so now we want to answer these questions. So how long would the 10th exercise be? So length of exercise time is E of n, so we're going to use our E of n equation. And 10th exercise is our n, 10, so it would be E of 10. Okay, so let me just scroll down here to get room. So I would do E of 10 equals 0.5 plus 0.25 times 10 minus 1, which is 9. So E of 10 would equal 0.5 plus 9 times 5 is 45, carry the 4, 9 times 2 is 18, plus that 4 is 22, so it's 2.25. So E of 10 would be 0.5 plus 2.25, which is 2.75 minutes. The other thing it asked for was, it said, if a player has 30 minutes of actual gym time during a period, how many exercises could she get done? Explain your answer. Okay, so now we move down here. So we would have to add the exercise and rest times for each row, starting with exercise 1, and see when the accumulated time exceeds 30 minutes. Okay, so to answer this question, remember it was, if a player had 30 minutes of actual gym time, how many exercises could they get done? So we would just extend our table here, and I will just fill in the data. So we're at exercise 5, and I chose exercise time, rest time, and total circuit time. So exercise time for exercise 5 was 1.5 minutes. 1.5 minutes. Exercise rest time for exercise 5 is right here, 4 minutes. So that would go here, 4 minutes. So total circuit time to do the exercise plus the rest would be 1.5 plus 4. But we're adding as we go. So total circuit time would be exercise 1 is 0.5 plus 0.25. Let me just get a calculator for this so we don't mess it up. Okay, so we're adding length of exercise time and rest time for the first 5 to get our total for how long 5 exercises would last. Okay, so I'll go to my home screen here. So I'm adding 0.5 plus 0.25, 0.5 plus 0.25, forgot my point, 0.25. Okay, so that's how long exercise 1 took. And then exercise 2 is 0.75 of exercise, 0.5 seconds or minutes for rest. So 0.75 plus 0.5. So now we're up to 2. So 1.25 and the 7.5 gives us a total of 2 minutes. So these 4 values total 2 minutes. Okay, so then plus a minute and another minute would be 4. So plus 1 would give us 4. And then plus 1.25. And then plus 2. And now we're up to 7.25 after 4 exercises. Plus 1.5 plus 4 minutes of rest equals 12.75 minutes after exercise 5. Okay, so total circuit time would be 12.75 minutes. Okay, then exercise 6. Now exercise time is going to be, how much is exercise time increasing? That was our arithmetic. So we were adding 0.25 every time. So that would be 1.5 plus 0.25, which is 1.75 minutes. Rest time was arithmetic. So we're multiplying by 2 each time. So just to make sure we're doing this right, 0.25 times 2, 0.5 times 2, 1 times 2, 2 times 2 is 4. 4 times 2 would be 8 minutes of rest time. So 12.75 plus 1.75 of exercise plus 8 minutes of rest would give us 22.5 minutes. So that's still less than 30 minutes. And then the next exercise would take 2 minutes because we're adding 0.25 to 1.75. So 2 minutes of exercise. And then 4 times 2 was 8. 8 times 2 is 16 minutes. So we take that 22.5 plus 2 is 24.5. So right there we're at 24.5 minutes. And then we need 16 minutes of rest, but the exercise is done here and it's less than 30 minutes. So it didn't say that we had to rest before the bell rang. We could rest on our way to our next class. So the answer to this question is we could do 7 exercises in 30 minutes. Okay, on to page 2. Example 1 says determine whether the sequence below is arithmetic or geometric, and find the function that will produce any given term in the sequence. So it says, is the sequence arithmetic? So keep in mind when we want to find an arithmetic sequence, there has to be a common difference. So 24 minus 16 is 8. 36 minus 24 is 12. So I can stop right there. Is this sequence arithmetic? No, there is no common difference. Is the sequence geometric? Well, to determine if they're geometric, you take any term and divide it by the previous term. 24 divided by 16 equals And if I just reduce this, that'd be 12 over 8. They're still even, so let's reduce it again. 12, half of 12 is 6, half of 8 is 4. And reduce it again. Half of 6 is 3, half of 4 is 2. So that equals 1.5. Okay? And then we do the same. But I'm just going to save some time here. Go to my calculator. And I'm going to take 36 divided by 24. And that is 1.5. So it's again 1.5. So we're going to keep doing that. And we do 54 divided by 36, and that equals 1.5. Take 81 divided by 54, and we got 1.5. So R equals 1.5. And is the sequence geometric? Yes. It has a common ratio of 1.5. Then it says, what is the analytical representation of the sequence? Okay, so what they mean is, what's the equation? So if we're going to call this some function with respect to some n, and it is a geometric sequence, you take the first term, 16, and multiply it by your common ratio, 1.5, to the power of n minus 1. And there is our representation of the sequence. Okay, exercise 1. Look at the sequence and determine the analytical representation of the sequence. Show your work and reasoning. 1. A decorating consultant charges $50 for the first hour. $50, 1 hour. And $2 for each additional whole hour. So second hour is $52, third hour is $54, fourth $56, $5, $58. How much would 1,000 hours of consultation cost? So if I look at this, 50 plus 2 is 52, plus 2 is 54, plus 2 is 56, plus 2 is 58. So we have a common difference of 2. So this is arithmetic. So you would say f of n equals the first term plus the common difference, which is 2, times n minus 1. So in solving for that, what do we ask for? Actually, I can simplify this. So f of n equals 50 plus 2n minus 2. I distributed here. 2 times n, 2 times 1. So 50 minus 2 is 48. So my function is f of n equals 2n plus 48, which is 50 minus 2. Now I want to find f of 1,000. So f of 1,000 equals 2 times 1,000 plus 48, which equals 2,048. So f of 1,000, in other words, 1,000 hours of consultation would be $2,048. Okay, on to page 3. Question number 2. The sequence below represents the area of a square whose side length is the diagonal of a square with integer side length n. What would be the area for the 100th square? Hint, you can use the square below to find the function model, but you can also just use the terms of the sequence. So first we want to look to see if there's a common difference. And looking at this, 8 minus 2 is 6, but 18 minus 8 is 10. So there is no common difference. Okay, so there is no common difference. Then we want to look at consecutive sequences for consecutive terms to see if the sequence is geometric. So 8 divided by 2 has to equal 18 divided by 8, and that has to equal 32 divided by 18, and that has to equal 50 divided by 32. Well, 8 divided by 2 is 4. 18 divided by 8 is 2 point something, so those are not equal. And same with this, 32 divided by 18 does not equal 18 divided by 8. And these are all not equal, so therefore it is not a geometric sequence either. But the first difference increased by 4. Okay, so I'm just going to write that in here. So now I'm just going to get rid of this. Okay, so to get from here to here, let me think about this for a second. Okay, so now I want to check the differences. So 8 minus 2 is 6. 18 minus 8 is 10. 32 minus 18 is 14. And 50 minus 32 is 18. So to get from 6 to 10, we had to add 4. To get from 10 to 14, we had to add 4. And to get from 14 to 18, we had to add 4. That tells me that it is a quadratic sequence. It is a quadratic sequence. Okay, so we know we have an n squared. All right, but if n is 1, 1 squared is 1, so I don't get my first term to be 1, so I need to multiply that by something. Well, what do I multiply 1 by to get 2? And that is 2. So I know my first term is 2n squared. So my f of n equals 2n squared. So if I plug 1 in here, 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is my 8. Put 3 in here, 3 squared is 9, 9 times 2 is 18. Put 4 in, 4 squared is 16 times 2 is 32. So my function is 2n squared. So now that I've checked that, I didn't write down what I checked, but you saw what I was doing. If I plug in 5, 5 squared is 25. 25 times 2 is, in fact, 50. So now I have this formula, and now I can answer the question. What would be the area for the 100th square? Well, that would be f of 100. So I put f of 100 in here would equal 2 times 100 squared. So that would be f of 100 equals, well, 100 squared is 100 times 100. That would give me 4 zeros. And then that'd be a 1 here times this 2, so that'd be 2. So it's 20,000. So the area of the 100th square is 20,000 square units. Okay, problem number 3. Let me change colors here. So to get from 3 to 6, I had to add 3. To get from 6 to 12, I had to add 6. So right there, there is no common difference. So now I want to know if there's a common ratio. So I do 6 divided by 3 has to equal 12 divided by 6 has to equal 24 divided by 12. Well, 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. So my common ratio is 2. Okay. So it's a geometric sequence with a common ratio of 2. And therefore, we can write the terms like so. Okay, and before I do that, let's just do the equation. So, since it is a geometric, I would say f of n equals the first term times the common ratio to the power of n minus 1. So, if I want to know what the 10th term is, that'd be f of 10. And that would equal 3 times 2 to the 9th. 10 minus 1 is 9. So just to save time here, I'm going to do 2 to the 9th, and that's 512. So that would be 3 times 512, which would equal 1,536. 3 times 2 is 6, 3 times 1 is 3, 3 times 5 is 15. So my f of 10, if I keep writing this each time, is the 10th term of the sequence would be 1,536. Okay, page 4 brings us to the end of the lesson. Review your lesson summary and go do your problem set.